Your online application's starting to fail. It's crawling on the network just as fast as a snail. We need evented programming starting from the top. Better write some code so the world doesn't stop. With the non-blocking model, we will be just fine. Built on Google Chrome's V8 runtime, and all you need to do is write some JavaScript code and use the real-time web with Node.
Welcome back to Node.js. My name is Eric Gatlin. I'm going to be leading us through the rest of this course. In level 4, we're going to be going over modules. In the first 3 levels, we've been using require to do stuff like HTTP and the file system, but what exactly is going on here? So how does require work? How does require find these libraries? And what does require return? How do we define what require returns? Well, let's look at what that would look like. In Node.js, when we want to share code, we create these things called modules. So let's create a function and we want to share that with our app. So we're going to create a custom hello.js file. In that file, we define a hello function. All it does is log out to the console. To define what we want to return when we require this file, we use the exports object. So here we're saying export the hello function. Now down below in our application, when we require that file, we have access to the hello function and we can call it. Another way we can do that, as you see here in custom goodbye.js, we can actually export a function into the exports object. So when we require it, an object is returned, and then we can call that function on the object. So here we're requiring custom goodbye, then GB is the exports object. We don't have to assign what is returned by require into a variable. We can actually just call require and then right away call the function that it returns, like we see here. You might notice here that we're using / in front of our module name, and we're going to go over why we're using that a little bit later. It has to do with how require searches for our module. In our previous examples, we've only exported one function, either by assigning the function to exports directly or assigning that function on the exports object. But let's say we want to export multiple functions. How do we do that? We can do that by assigning multiple functions in our mymodule.js file to the exports object like we see here. Now our module exports 2 functions, foo and bar, and it keeps the baz function private, which means that our app.js won't be able to use it. But if you tried to call baz, it wouldn't work. Let's walk through a real-world example of creating our own module. And for this, we're going to introduce a little bit of new functionality with the HTTP module. Instead of creating a server and responding to requests, we're actually going to make a request. So we're actually building a HTTP client. First, we're going to require our HTTP module. We're going to have a message that we want to send in the request body. So we define that. Next, we'll define an options object that will eventually be turned into a URL for the request. Then we'll call the request function on our HTTP module. That function accepts 2 parameters. Our first one is the options for the URL that we're going to make the request to. And the second parameter is a callback that passes in a response, which is a readable stream, so we can read data back from the response and just print it out to the console. Finally, we write our message to the request body, and when we call end, it'll finish the request. So our first step here is let's encapsulate this functionality using a function. We'll call it makeRequest. And now when makeRequest is defined, we can use it like this, and all we have to do is pass in the message body that we want to write to the request. So now we have our makeRequest function, but we want to use this across multiple different pieces of our application, maybe multiple different files, or maybe we even want to share it with someone else on our team. So we would want to create a module. As you can see, we've moved our makeRequest function into a new file called makeRequest.js. And now all we have to do is assign the makeRequest function to the exports object. Then to use this module, we go back to our app.js and we require makeRequest. And then we can use it just as we were before. You might be wondering, where on our file system is require looking for our makeRequest module? When we require with /makeRequest, we're telling require to look in the same directory. We could tell require to look one directory up using .. my module, and these are relative paths. We could also just pass in an absolute path to our module. But what happens when you just pass in the name of the module, like make request, without .. or .. in front of it? By default, what it's going to do is search in the node modules directory. So as you can see here, we're in home Eric my app app.js. So when we require make requests, it's first going to search in home Eric my app node modules. If it doesn't find it there, it'll keep going up one directory and searching in the node modules directory. So now that we know how to create our own node modules, it'd be nice if there was a way to easily install third-party modules from the community. And luckily, Node comes with something called NPM, stands for Node Package Manager. NPM is a lot like RubyGems for Ruby or CPAN for Perl. It has a central repository where people can publish their modules and you can install from. NPM comes with Node, so it's really easy to install. If you have Node, you already have NPM. It hosts a module repository on a server. It also has tools for dependency management. It makes it really easy to publish your own modules. And it follows a local-only install mode that we'll go into a little bit later into why that's important. First, we're going to look at how easy it is to install third-party modules with NPM. Here you can see I'm using the NPM command line tool and I'm saying npm install request. And that's going to install the third-party request library. As you can see here, it's going to install it into the local node modules directory. So remember before when we saw that require searched in the node modules directory? Well, as you can see here, when npm installs that module into node modules, we can automatically require it in our app, and it'll work. When we did npm install request, you saw that we installed that module in the app's local node modules folder. But let's say we wanted to install something like CoffeeScript. It comes with an executable called Coffee that we might want to use to compile CoffeeScript files to JavaScript. So we can't use the local install. We actually have to pass this flag -g that'll install the CoffeeScript globally. And then we can call the Coffee executable. So the rule of thumb here is if the module has an executable, you need to use the global flag when installing it. One thing to note though is that you can't actually require global modules. You have to install the module locally, and then requiring the module will work. There are a lot of places you can go to find NPM modules to use in your applications. NPM has its own registry where you can go and search for modules. You can actually search from the command line, as you can see here, using npm search. You can always go to GitHub and use their search. And there's this really great website called Node Toolbox where they list the best modules based on their category. After a while, when you're building your application, you're going to start installing more and more NPM modules. So it would be nice to have a place where you can define which modules your app depends on. NPM makes that really easy. All you have to do is define a package.json file in the root of your application. This file contains a JSON literal. All you have to do is define the name of your application, which version it currently is, and then you can pass in a dependencies object. In the dependencies object, we simply list the modules that we depend on next to their version numbers. After we have this package.json file defined, we can actually just run npm install from our app, and it'll go out and install all of our dependencies for us in the node modules directory, as you can see here when we install the connect dependency. You might depend on modules that have their own sub-dependencies, like our connect module here. And when you run npm install, it's smart enough to go out and also install those sub-dependencies. But it's not going to install them all at the root node modules folder. It will actually install in the connects node modules directory. As you can see here, under connect node modules, we have the three dependencies, QS, MIME, and Formidable. The great thing about this is it actually prevents a lot of problems that have to do with conflicting modules. So imagine instead if it installed all the module dependencies in that one folder. One thing I think we should cover before finishing this level is semantic versioning. Now, semantic versioning is a way to give meaning to version numbers on dependencies. So as you can see here, we defined our version number on Connect as 187. The 1 indicates the major version, the 8 is the minor version, and 7 is the patched level. What that means is that you don't have to specify the exact version number in your package.json dependencies. By using semantic versioning, we don't actually have to put the exact version number in our dependencies. We can use what's known as ranges. As you can see here, we can use the tilde to define a certain range. When we do tilde1, that means when we do an npm install, as long as the version is greater than 100 and less than 200. This is considered dangerous because any changes to the minor version could break your app. We can make it a little safer by doing tilde 1.8, and this would mean npm would install anything greater than or equal to 1.8 and less than 2.0. This is still a little bit dangerous because the API of Connect could change from 1.8 to 1.9. The safest way to define a range and still have the dependency considered safe is to use tilde 187 or tilde major minor patch. What this means is that npm will install anything greater than or equal to 187 but less than 190, which means that when running npm install, you'll only get patch updates for Connect, which means it shouldn't break your application. We've reached the end of level 4. Have fun in the challenges. We'll see you back here for level 5.